Now that we know how to find the slope for parallel and perpendicular lines, let's look at how to find the equation. So in order to find the equation, most often you're not going to have the y-intercept. So what we're going to do is we'll use that y minus y1 is equal to m times x minus x1. Okay, so we'll use that point slope form. In this first one, it says for the line that goes through the point 3, 12, so there's our x1 and our y1. We're looking for a line both parallel and then a separate line perpendicular to y equals 20 minus 4x. So the first thing we need to do is find the original slope here. So our original slope is m is equal to -4. And since this is a parallel line, we know that our new line is also going to have the same exact slope, at -4. So my equation will be y minus y1, so that's y minus 12 is equal to -4 times x minus 3. So that just gives me my parallel line. And then for the perpendicular one, if the original slope was -4, I need to flip that over, do 1 over that slope. So my new slope is going to be 1/4. And then this was negative, so this one needs to be positive. It needs to have the opposite sign. So we have a positive 1/4 as our slope. And then we'll still use this same x1, y1. So I have y minus 12 is equal to positive 1/4 times x minus 3. So really the only difference between these two, because they're going through the same point, is just that slope. So that parallel one was -4 and the perpendicular one was positive 1/4. Now I do want to graph these in Desmos so we can look at these and at least convince ourselves picture-wise that this really is a parallel and perpendicular line. So to put these in Desmos, you do have to have it in the form y equals, but that's really easy to accomplish if I just add that 12 over to the other side like this. And I don't even have to simplify it. I can just add it over there. And so I'll do the same thing for this one. And then let's go take a look in Desmos and see what these look like graphed. Okay, so here we are in Desmos, and I have graphed the line and the points. This is the original line, y equals 20 minus 4x, and that point 312. So let's put in the parallel line. We have y is equal to -4 times x minus 3 plus 12. Okay, and so there is our parallel line there in green. And you see it does go through the point, and it definitely does look parallel here to the original red line. And then let's do the same thing with our perpendicular line. So that one had a slope of 1/4. And then that'll be times x minus 3. And then I need to add that 12 back on there. So it also goes through that point 312. And sure enough, it does in fact look like it is a 90-degree angle where it meets up with both the red and the green lines. Okay, so hopefully that's at least a little bit convincing that we did actually get to the right spot there. And we did find the things that we were thinking we were going to find. All right, now that we've done one of those together, I'd like you to go ahead and pause the video and give a try on the other one. So same kind of idea, just a slightly different equation and point, and then we'll come back and try them together. All right, so hopefully you gave those a try. Let's see how this worked out. So here's my x1, y1, my 210. And then the slope for the original one is m is equal to 5, so positive 5. So my line that is parallel is going to be y minus 10 is equal to 5 times x minus 2. And then my perpendicular line, so I need to find this new slope. So instead of 5, I'm going to do 1/5. And then I need to change the sign. So this one was positive, which means this one should be negative. So then my equation is going to be y minus 10 is equal to, and my slope is -1/5. And then this will be x minus 2, or x minus x1. All right, so hopefully that worked out well for you. And there are a couple optional videos that are coming up next. If you're kind of struggling with solving equations, it's up to you whether you do them or not.